In this video, we're going to look at solving two equations with two unknowns. So we're going to start here. We have two equations, y equals 40 plus 4x and y equals 100. And the easiest way to do this is to set y equal to y. Just set both equations equal to one another. So setting y equal to y, 40 plus 4x equals 100. We're going to subtract 40 from both sides. And then we're going to divide through by 4. So x equals 15, and y at the beginning equals 100. So y technically wasn't unknown, but this is the simplest case here of two equations with two unknowns when actually one is not quite unknown. All right, moving on. Number 2, we got two equations, two unknowns. Q and P are the variables that are unknown. So we can do the same setup. We're just going to set Q equal to Q. We got two equations, two Q equations, set them equal to one another. So we get this step here. Let's collect the P terms. So adding 2P to both sides, we get 4P, and subtracting 25 from both sides, we get 4P equals 50, and we're going to divide through by 4. P equals 12.5. Now we need to figure out what Q is. We can take this 12.5 for P and plug it back into either of these equations. If we did our math right, we'll get the same answer. So here Q equals 25 plus 2P. So I'll put the 12.5 in for P now over here. And solving, we get 50. And like I said, I could have plugged this 12.5 back into the other equation. You would have got 75 minus 2 times 12.5. You would have had 75 minus 25, or once again, Q equals 50. Moving on. Two more equations, y equals 50 minus 2x and y equals 3x. Set y equal to y. That'll eliminate the y. Doing that, we get this, adding 2x to both sides, 5 equals 5x, dividing through by 5, x equals 10, and we'll take this 10, we can plug it back into either one of these equations. I picked this one here, so y equals 3x, when x is 10, like we found, y will be 30. I'm just showing you we could have plugged this x equals 10 back into this first y equation to also get 30. Number 4, we got two equations and two unknowns. We could have, if we want to, we could solve this other equation here for y and then set y equal to y. But I'm just going to basically do a sort of a substitution method here, where I have x in this first equation. I'm going to plug in y divided by 3. Okay, so this is just another method of solving two equations and two unknowns. Just where we have an x. Well, what is x? It's y divided by 3, so I make that substitution. And we get this result, and now I'm going to just solve it for y. We got one equation and one unknown. So adding 2y divided by 3 to both sides. Getting a common denominator on the left-hand side here. We get 5y divided by 3, and that equals 50. And then let's multiply everything through by 3/5. And if you do that, we get y equals 30. To get the x, the easiest thing to do here would take this 30 and plug it in on top here, and we'll get x equals 10. We could have also took this y equals 30 and plugged it in here, but we'd have had to do a few more steps. Okay, so the most direct way would take this 30 and plug it into our x equation to get x directly. All right, moving on. have a Q equation and another Q equation. We can just set them equal to one another as before. I'll go through this one a little faster. We've done some already like this. Collecting or adding, or what did I do? I collected the p terms, added p to both sides. P equals 40. Plug this 40 back into either equation, and you're going to get Q equals 60. Here's another equation. I'm going to look to make a substitution in this case. So 90 equals x plus 4y. Well, what is y? 2x. So what I did is I took this y equals 2x, this 2x part, I plugged it in the y over here. Simplifying, 4 times 2x is 8x. Dividing through by 9, x equals 10. To get y, we'll just take this 10 and plug it in here for x. And there we go, y equals 20. Moving on. Here we have two equations and two variables. Once again, we got this q subscript 1 variable and q subscript 2 variable, so these are two different variables. The application this is really coming from, this would be like the output of firm 1, and q subscript 2 would be the output of firm 2. So here I'm going to do a substitution method. So in this first equation here, this q subscript 2, I'm going to replace it with 30 minus 1/4 times q subscript 1. So that's what I got in parentheses here. This is q subscript 2. And now just simplifying, minus 1/4 times 30 gives us this, minus 1/4 times minus 1/4 q subscript 1 gives us this 1/16 times q subscript 1. 30 minus 7.5 gives us the 22.5. Subtracting 1/16 q subscript 1 from both sides, we get this result now. And then the left-hand side will just simplify to 15/16 times q subscript 1. Multiplying through by the reciprocal of 15/16, or 16 divided by 15, q subscript 1 is 24. Taking this 24 and plugging it in over here, we get q subscript 2 also equaling 24. Moving on, we got two equations here. And in this one, I want to solve y as a function of m. So in other words, we want to solve this for y, where y is a function of m, this m variable here. And then we're going to do the same thing for x. We want to solve these two equations, these two unknowns, where x is going to be also a function of m. So I'm going to take this right here, and I'm just going to solve it for y. So y equals 4x. And I'm going to plug that into the m equation. Where I see y, I'm going to plug in now 4x. So that's what I did. Here's our m equation. Y is now 4x. So m equals 6x, and dividing through by 6, x equals m divided by 6. So here we solved x as a function of m. And we'll do the same thing for y. Here we got y equals 4x. Well, what is x? M divided by 6. So I make this substitution of m divided by 6 into this equation up here. And now we got y as a function of m. Y equals 2m divided by 3. Got a couple problems here, 9 and 10. Let's start with 9. Two equations and two unknowns. We want to solve for x and y. So the first thing I'm going to do is I'm going to take one of these equations, in this case, this second one here, and I'm going to solve it for y. So simplifying this equation for y equals 5 minus 3x. And after I do that, I'm going to substitute it into the first equation. So our first equation is 4x minus y. Well, what is minus y? Y is what I have over here, 5 minus 3x. And now we got one equation and one unknown. Simplifying this, first I distribute this minus term, and then adding 5 to both sides. We'll see that x equals 1, and then plugging this back into over here where I have minus 3x. I'm going to plug in 1 now. We get y equals 2. And we could do the same problem with another method of two equations and two unknowns, and that's the elimination method. So I'm just going to sort of stack these equations, and then I'm just going to replace the second equation by adding the two equations together. So just add these two equations up. 4x plus 3x is 7x minus y plus y. That eliminates the y term. And then 2 plus 5, we get 7. And once again, dividing through by 7, x equals 1. Plugging that x equals 1 into either equation and solving, we're going to get y equals 2. So that's what I did over here. 4 equals x. X is 1. Subtracting 4 from both sides, you're going to get minus y equals minus 2. Losing the minus terms, y equals 2. Let's do another elimination method. Here's one equation. Here's the second equation. So we want to do some operations on these equations to try to eliminate one of the variables. What I'm going to suggest to do is multiply the first equation by 5. So it'll be 5 times 3x minus, or 5 times negative 2y, and then 3 times 5. And the second equation, we're going to multiply it through by 2. So here's our first equation multiplied through by 5. Here's our second equation multiplied through by 2, and now I'm going to add them. And so why did I choose 5 and 2 here? Well, if we were to add these equations now, the y terms would cancel. So we could have picked other, other numbers to multiply it through. Maybe we wanted to eliminate the x's first, so we could have multiplied the first equation through by 2 and the second equation through by minus 3. Therefore, you would have eliminated the x term, 6x plus a negative 6x. It would have canceled. So there's no right or wrong in doing the elimination method here and which x or y you want to cancel. All right, so adding these up now, we get 19x. Adding up the y terms, they cancel. 15 plus a negative 2 is 13, and we get x equals 13 divided by 19. Plugging that 13 divided by 19 into any of these equations, I pick the first one. Simplifying this to solve for y. 3 times 13 is 39. Moving this 39 divided by 19 over to the other side. And simplifying further. Dividing through by 2. Y equals negative 9 divided by 19. And that is it. I hope you found this video helpful.